Joining us for a very exciting session here about Amazon CodeGuru is Danielle Tsvetkova from the Amazon CodeGuru team. Daniela, thank you for taking the time today to talk to us about this.
Thank you, Nick, and really good to be with you.
Awesome.
Welcome, Daniela.
Yeah, welcome. This was a launch that I think made a pretty big splash back at reInvent. I know a lot of people have been waiting in anticipation to see more of it, see it in action, and we will get into that a little bit later. But let's start very, very high level. Daniela, what is CodeGuru?
Sure, Nick, I would like to answer this question, but before we go into this, let's go into what problems it's actually solving. And I'm going to switch to my screen.
Sure.
Okay. So imagine a typical week for a software developer.
Oh, hold on, Danielle. I don't think you're sharing just yet.
Oh, I'm not sharing. True.
So it's the beauty of live production.
Yeah.
Awesome. You're coming through now.
Okay, now let's get back to our typical week.
How meta, by the way. Video stream not sharing is very typical of the typical software developer.
But if you're a software developer, most likely you're spending a lot of time writing code and reviewing the code, building it, testing it, unit test, performance test, all of that, deploying it, running it, enabling some sort of monitoring and logging. And sometimes there could be issues, in which case you would need to resolve them. And then rinse and repeat. And then in a typical week, or let's say a month, if you're lucky, what could happen is that you have buggy or inefficient codes that somehow doesn't get caught during code reviews. When you run your tests, sometimes you don't have sufficient coverage. And when you set up your monitoring, I mean, monitoring is great. You need to make sure that you set up all the alarms and metrics correctly. And oftentimes when you have those alarms, it means that it's already too late, the problem has happened. In addition to that, you also have cost issues related to your application. So is your application efficient enough? Are you running it the way that, in the most economical way, or are you spending more money than you should? And finally, when you have operational issues, oftentimes, it takes longer than you would expect. This means that, you're not able to go back to writing your code, creating new functionality, but also you're impacting your customers and your business. And so with this in mind, we created Amazon CodeGuru to solve these problems. And CodeGuru is a developer tool which is powered by machine learning. And it provides intelligent recommendations to improve your code quality. And it also identifies your applications, your live applications, most expensive lines of code. And it actually has two distinct features, which we're going to go into deeper detail later. But very briefly, we have Amazon CodeGuru Reviewer, which is a service that uses machine learning to identify important critical issues that are difficult to find even by sometimes the most experienced engineer. With this, you improve the code quality of your application. And in addition to that, you get recommendations how to fix those issues. With CodeGuru Profiler, you can optimize the performance of your application because you get help on identifying the most expensive line of code. You get help troubleshooting performance issues. And on top of that, as an extra bonus, you can improve the cost to run your application, the infrastructure cost. Just to give you a very brief overview of where do these two services play in this whole software development lifecycle. You have CodeGuru Reviewer that provides these code reviews during your the phase where you write and review your code. Then Profiler plays in several places when you do your performance testing. you want to make sure that you catch any performance issues before they even get to production. Now you can ask me the question, well, why don't you catch those problems with reviewer? And the truth is that to some extent, reviewer can catch some of them, but what you want to avoid is the trap of premature optimization. This means that you really want to optimize code where it impacts you in the live application. There's no point trying to optimize everything. And then finally, you are going to run Profiler on production. It's going to run continuously with very low overhead, and you're going to catch all these anomalies that Profiler is monitoring, so that you know early in advance when something is about to go wrong. And finally, when you have an issue, you can use the insights that the Profiler provides for the most expensive lines of code, as well as the visualizations that tell you where you're spending the most of your time. So I'm going to close out my screen.
Sure. Yeah. And so, that was a great overview. There's, it's clear that I think to a lot of people that have authored software before and have to deploy it and manage it, that there's a lot of problems and friction points in such a process. I know when you said writing bugs in your code is part of the typical software process, my eyes lit up, because that's all of the code I write has bugs, many of them. But it really feels like these two, the profiler and the reviewer, are two main phases, right? Like, one is sort of like the static portion of, like, analyzing the code as is, and then there's sort of the more active portion with profiling it to achieve insight as to, like, expensive lines of code and downstream, like, optimization of how that code runs separate from just the bugs that exist sort of inherently, right?
Yeah.
Now, Danielle, I'm going to break protocol here and ask you a question about a future feature. When is CodeGuru going to be able to write code for me?
Are you sure you want somebody else to write code for you?
Absolutely.
If it uses machine learning, why not?
Yeah, I welcome our machine learning overlords. In all seriousness, I think you made a lot of really good points, and I think that some of them deserve a slight bit of elaboration, because they're really, you really need to kind of do this for a while before you appreciate how useful a tool like this is. You mentioned premature optimization. I want to share a very, very short story here. So when I was working at Microsoft a couple years ago, I still remember to this day, we had a code review, and this is to your point of, like, what kinds of things can code reviews catch? And I was working with a very talented teammate, and he said, "You're making a copy of this string. You shouldn't do that." And we spent, a long time debating about the impact of copying this string on the actual performance of the application. And it turns out that through a lot of manual profiling, that copying that string did not affect the performance of the application in the slightest. Now, what we did discover unexpectedly is that our application was spending a long time in places that we had never expected, right? And I think this concept has been reinforced over and over and over again for me, where I now have zero trust in my ability to, in advance, identify where the code bottlenecks will be. Often when I think that a particular area will be slow, I'm like, oh, look, we're doing a O of n squared loop over here, right? That's going to be slow. We know O of n squared is bad. Can we make this log n? So we spend a day fixing that out. It turns out if n is not large enough, it doesn't matter. Yeah. So we end up wasting time fixing things that are not the bottleneck, while the things that are bottlenecks just kind of slip by, right? Especially in the age of modern package managers, you're like, oh yeah, I don't want to do that. npm install, and then call some other package. And it turns out that package is extremely slow in your critical path, and that introduces a huge performance bottleneck. So I think this idea of premature optimization really kind of slices two ways. It has something to do with the fact that we're just not very good at identifying where the bottlenecks in our code are going to be. The system is just too complex to keep in your head, and we're not good compilers. Our brains are not built for that, right? And so having software and tools that help you do that is really important. And I really appreciate that we have a feature like that here.
Yeah, and you mentioned something really important, and it's the element of surprise. And I cannot stress this enough. You think that you know your application. I've seen so many developers looking at the application runtime data with the profiler saying, well, I didn't expect my application to spend so much time here. And it happens over and over.
Yeah, absolutely.
Yeah, so I think we've sort of arrived at this outcome where it's, you know, it becomes an insurmountable challenge for people to be their own best tools for introspection of profiling their code. So the obvious answer to me is, okay, well, let's profile our applications. But it seems that a lot of companies are not doing this. So Danielle, I know you're far more in the loop on this than I am. Why are companies not profiling more often with automated tools, and how is CodeGuru changing this?
So, I mean, there are multiple reasons why this is not happening as much as it should. One of the reasons is the perception that profilers are difficult. And I've spoken to engineers who say, well, it's difficult, it takes time, I don't have time. This is more meant for performance engineers. I'm not a performance engineer. Well, it doesn't run on production. Then you tell them actually some profilers run on production, while it requires setup. So lots and lots of reasons. And the other one is deciphering all the information that profilers provide. It's a bit of a learning curve, and people just, you know, they first need, people need to see the benefit before they invest the time. And I think that one thing that I've seen is that there's just not enough understanding of how extremely useful profiling is to help the performance of your application. I just feel like there's not enough good stories of personal wins achieved by using profiling. Now, what CodeGuru Profiler does is it cuts across all these difficulties of, oh, it's too much information, I don't know how to use it, and with the feature that I'm going to show later on, which is the recommendation reports, it really looks at your runtime application and it says, well, this is the problems that I identified and this is how to fix them. So it doesn't get any simpler than that. Well, maybe simpler is that it fixes the code for you, but we're working on that.
The simplest UX is where it just writes the code from the start and there's no need to make amendments at all. But that I'll leave that PR FAQ to Rob at some point in time. So awesome. So profiling traditionally seems to have this tough reputation. People this ownership problem of maybe it's not in my wheelhouse to be doing this. So with CodeGuru, I'd imagine here that I heard a little rumor that this was like we've had similar tools internally, and that was the inspiration to being able to bring CodeGuru to other people because we saw many performance gains using it, and we know that other developers would see that as well. Is that true, or am I just totally making things up?
Absolutely true. We've been running CodeGuru Profiler internally on many applications and for the last several years, and it's been a phenomenal success. We have saved so much money in different ways, and I'm going to go really deep into this, what we mean by saving money and most expensive lines of code and what all that means. But due to the phenomenal success that Profiler has had internally, we said, well, it's making our life easier. It's saving us money. Let's make it available to our customers.
Yeah, always an exciting value proposition. Being able to, it's like making a piece of software and putting it out in the world and hoping people like it is one thing, but knowing that at Amazon scale we've used this and achieved a lot of value is almost like, well, we know that customers are gonna, get value out of this too. So always a nice origin story.
I want to hear more about this most expensive line of code.
Sure. So what we mean by most expensive lines of code, it's the sort of expense that you really don't want to spend and that you could have saved yourself spending. And us helping you find that wasteful line of code or dangerous line of code is going to save you all this money. So what does that mean? It's the line of code that can cause your application to crash or have performance issues. Is the line of code that is going to have a make your application run in a more costly way. It's the line of code that's going to prevent your developer from spending their time developing new functionality because they have to fight the problem. And basically it's the thing that shouldn't have happened, and yet it happens, and we provide an answer how to fix it.
Yeah, actually, now that you mentioned that, I want to connect this with one of the threads going on in chat here. I think Tesseract, if I'm pronouncing that name correctly, is asking why we run this thing continuously as opposed to running it in an endurance or a stress test. And let me put that question to you, but also kind of start it off with a thought of my own. It occurs to me that one of the benefits of running this thing continuously is the time to detection of an issue, right? So imagine that we've been building a piece of software together, and we've been working on this for years, and we've never run a profiler. And we suddenly turn the profiler on, or we run the profiler within the context of a stress test, and we discover all these performance problems with it, right? How exactly do we go about fixing that? The act of fixing that itself, by the way, is going to introduce more bugs, almost certainly, right? And so depending on what the situation is, it might be a very, very expensive process to kind of work back that technical debt. But I think one of the benefits, at least to me, is that when you run a continuous profiler, you're detecting performance regressions. You can establish something like a performance baseline, and per check-in, you can say, in the integration environment, does this regress the mainline performance of the following test cases, right? And the reason why I feel like that's nearly a superpower is because there's this very interesting relationship between the time that the defect is discovered and how much it costs to fix. And there's some research out there that indicates that this actually goes up exponentially. So if you can catch a defect, let's say while you're coding or while you're designing or in the test phase, before the feature ships out to live customers, it's actually relatively easy to fix because you're not dealing with all of the consequent features and the relationships that code has to other pieces of code. But if you discover a bug a year later and all these layers of code have been added on top of it, it's very, very difficult to tease it apart, right? And so I think that's my take on the value of continuous monitoring. But what are your thoughts on that?
Yeah, absolutely. I mean, you want to do it at the earliest possible phase or stage where it makes sense. So in other words, what we said earlier, you don't want to prematurely optimize. So you're going to be running reviewer so that you catch all the defects to the extent possible. And then you're going to be stress testing or performance testing under load your application to try and catch as much as possible from any of those performance issues that your code may have introduced. And to do that, you'll be running synthetic load, which is trying to emulate, but not 100% a real production environment. And then once you run the profiler, your application on production with the profiler all the time, it's going to continuously monitor for deviations or anomalies, the performance of your application, and it's going to find these most expensive lines of code. It's going to be providing this data available for you for if something crashes or has a performance issue, so that when the problem has already happened, the data is already there for you. If you were to enable it only when the problem happens, then it might already be too late, because you want to be seeing, well, how did my profile look when things were good? And how does it look now that things have gone south?
So we've really sort of delved into the category of essentially how this profiler is working under the hood. So when we're thinking about applications that this can work for, are there any limitations or any particular classes of applications that CodeGuru Profiler is compatible with?
So currently, CodeGuru Profiler works for JVM, any application that runs in the JVM, so Java, Kotlin, Scala, Clojure, and so on. And it supports any sort of compute environment. So this means EC2, ECS, EKS. It runs also on AWS Lambda and even on on premises.
And one other part of that, when I think about using a new tool that's going to, track the performance of my application or measure it in some way, I immediately start worrying, what sort of setup or integration cost is this going to yield for me, right? Do I need to change code? Do I have to inject decorators in my code to run this profiling? What does that look like for CodeGuru?
Yeah, so I can show you a very extremely quick demo for this, and the answer to this is no. You don't need to change codes. All you need to do is to start your application with a command line Java agent switch, and and that's it.
Sure. Do you want to walk us through that now, or we can do that in a little bit? Up to you.
We can do it in a little bit.
Okay, cool. Also, I know some people are talking in chat. Danielle mentioned previously that there's two main components to CodeGuru, the profiler and sort of the I believe it's the analyzer, or the reviewer. I'm blanking on the second one. Reviewer. We actually will have a second guest on in just a little bit that will talk about reviewers. So we're diving deep here on the profiler. We'll see a demo of that, and we'll also get another guest with another demo for reviewer later on. So sit tight. We're not ignoring your questions in chat. We'll loop those back in just a bit. But again, sort of bringing the conversation back, you mentioned, again, establishing a baseline is imperative because if you're already sort of experiencing troubles in production, you have no standard or normal baseline to compare to. Do you want to talk a little bit about sort of those algorithms or the anomaly detection around how CodeGuru Profiler decides that things may be awry?
Yeah, absolutely. So CodeGuru looks at the profile of your application. And what is a profile? A profile is essentially an aggregation of the stack traces of your application over a given period of time that have been, smashed together, aggregated. And we know where you're spending, in which methods you're spending, what percentage of your time, or active CPU time or workflow time. Anomaly detection works on the line of code level or the method level where the machine learning algorithms have been written in such a way that a CodeGuru profiler knows which methods to monitor for anomalies, and it continuously adjusts itself over time so that it knows what constitutes an anomaly versus not. Because, for example, when you have seasonality, that's not really an anomaly. It's just something that happens all the time. So we want to reduce the noise to the extent possible. And then when this happens, an anomaly is something that really changes, and it's something that you want to look into. It could be CPU suddenly spiking up or CPU going down. In addition to the machine learning algorithms automatically detecting anomalies, you as a developer can also further, if you want, help CodeGuru Profiler to learn based on what you think is an anomaly. And I'll show you shortly what I mean by that.
So real quick thing here, based on everything you described so far, it sounds like CodeGuru Profiler is a sampling profiler. Is that correct?
Yeah, it's correct. The reason why it is a sampling profiler is because we wanted to reduce the overhead. So profiler collects only enough data to be statistically significant. It usually does this by sampling the stack traces every 1 second on some or all of your instances. It depends. Like if you have a lot of instances, we're not going to run on all of them. But again, it's all about statistical significance.
Yeah, so interesting. The 1 second runs once per second, but you also mentioned earlier that you can run this with Lambda and EKS. So is this going to run once per second per instance of the JVM?
It's algorithmic, so this is the average, but it's going to change based on how the control plane is making it run. The point that I'm trying to make is that we are trying to limit the overhead to around 1% CPU utilization.
Sure, yeah, but I mean, because you mentioned also earlier that you have to gather statistically significant data, right? If you're sampling once per second, I run for 10 seconds, I don't have enough samples to really form a picture of what's going on with my. So do you have does our model kind of capture at what point we have statistically significant data that we can trust?
Yes, absolutely does. We have this mathematical brain or statistical brain that knows how much is enough, and that is also varied for Lambda because Lambda starts and stops, and the control plane knows at what point it has gathered enough information.
That is really cool. I'm really glad you brought that up.
Yeah, one of the things that's becoming really clear to me, I've never performed extensive or automated profiling of an application. I've done some manual testing here and there, but it is sort of bridging this gap between the actual capability to capture the necessary data, but then also this giant leap forward of actually making that information digestible and actionable, right? Because the things you've described so far, Daniela, are like, okay, well, there's going to be some sort of report or an output of this so that I don't have to just read raw logs. There's also this, anomaly detection so that I can understand that I'm actually looking at data that probably means something. There is some sort of deviation from the norm here, and even with the sort of knobs to tune to make that even easier, I don't have to worry about running tests to see if my algorithm is going to detect the problems I want it to. A lot of this sort of last mile problem of detecting or again making this data actionable is sort of dealt automatically through Profiler.
Exactly. Yeah.
Awesome. So we talked a little bit about, you said there's some automation under the hood with how this would work on a fleet, or multiple pieces of infrastructure. I mentioned here at the top of the broadcast that this was announced by Andy Jassy in the keynote over at reInvent 2019. I believe there was a launchpad session covering a little bit about this, but some months have gone by now. Is there anything in particular that's new with CodeGuru Profilers since when we first announced it that folks may not be familiar with?
Yeah, absolutely. So some of the features I've already mentioned. So anomaly detection using machine learning is a new feature. I'm going to show you briefly what it looks like. Support for AWS Lambda profiling is also a new feature. Another one that I can think of is improvements in the visualizations, which I haven't talked much about, but I will show you what they look like, where we tell you, well, this color, I call it color my code. Essentially, it's a way for us to tell you this code here is yours, and that code here is a library that you're calling or a framework. So it really helps you look at the code that you can actually change. Another one is ability to send, set up CloudWatch metrics for the recommendations. And also, we now show you the dollar value of the recommendations, which is super cool, because that can help you improve the prioritization of all these issues that we find for you. To look at the dollar value, I mean, you can make up your mind which one you want to fix first.
Wait a second, Danielle. Does that include the cost of your software engineering team?
This one is priceless.
Yes, of course.
Well, I feel bad because every time I try to ask you for some more context, Danielle, you're like, yeah, and I'll show you eventually. It'll be clear when you see it in action. So, I think we all have a very good understanding of sort of where Profiler fits in, and I guess I can speak on behalf of everyone here by saying, are we going to be able to see this in action? I know that's what we promise here on What's Next, but are we going to be able to see a demo for Profiler today?
Absolutely. I'm going to share my screen now.
Great.
Okay.
Awesome.
All right, can you see everything?
Yeah.
Perfect. Cool. So I've jumped really like straight into the recommendation report. So remember, I told you we find the most expensive lines of code or the deviations from normal. So this is for the application, which by the way we call profiling group. Image processing web app, and as you can see, we have 5 recommendations. Now, what is a recommendation report? It actually consists of 2 types of messages. One is anomalies, which are things that could impact the stability and reliability of your application. And the other one is a more specific assessment of how performant your application is and what is wrong with it specifically, with an explanation of how to fix it. So let's go through the anomaly first. So as you can see here, we have an anomaly with the file zip file.getEntry. You can clearly see that this is an anomaly. The reason why we flagged it as such is because it's taking an unexpected amount of block time. And you can see time series graph where you have this big blip here. And you can hover over it to see what's the percentage increase. You can also get the SMS notifications when you have such anomalies. And as I mentioned earlier, you can give us a thumbs up or thumbs down if you, which kind of reinforces the algorithm to know, okay, well, yeah, thumbs up, definitely this is a problem, or you might want to reconsider this. I don't agree with that. And it's not something that you have to do, but if you do it, it's just going to teach the machine learning algorithms faster. So that's, yeah.
Well, so I was going to say, with a graph like this and the concept of an anomaly, and I see a percentage on that screen, this makes me think a lot about, let's say, monitoring the average percent CPU utilization on my cluster, but that's quite different from what CodeGuru Profiler is doing here, right? What we're seeing is that the Java util zip file get entry method, I suppose, or whatever it's called here in Java, is using an unexpectedly high amount of CPU utilization, which is measuring something entirely more granular. Like, the expectation here is that this one line of code, obviously we may implement the change, but it should not have extremely variable amount of percent performance time or relative percent utilization time, right?
Yeah, you bring a very good point here, and I would like to take a step back. So yes, there are absolutely many anomaly detection services that look for anomalies. And however, what CodeGuru Profiler does, it goes really deep into the runtime data of your application, going down to this line of code or a method name to tell you, well, you know what, something is wrong with this one, you need to watch over this one. It's really important to understand that when higher order metrics or higher level metric like CPU utilization, that there's a spike, I mean, it's already too late. Whereas what we've observed with CodeGuru Profiler is that it's a very sensitive anomaly detection, because it finds these subtle changes in your application at the method level, and oftentimes this happens well before the problem has developed into a full-blown incident. So this gives you this extra time to notice that something is going off, look into it and fix it before you pay the big price.
Yeah, and something like this, an anomaly like this, would be causal towards your cluster or your infrastructure you're having higher utilization. So when you're actually trying to get to or performing a root cause analysis, CodeGuru Profiler gets us much closer to resolution here than just understanding. And obviously they both exist in different parts of the pipeline and for different reasons. But this is just another level deeper than users have been able to access previously.
Yep. Okay. So going down the list, so I mentioned there's two parts to the recommendation reports. One is the anomalies, and the other one are performance issues. So the performance issues are related to really expensive lines of code. Those are inefficient use of in this case, Java. They point to issues with your code for which there is a better way to write this code. Let's look at the anatomy of a recommendation. So I'll just go all the way to the bottom. Repeated Jackson object mapper creation. So this is a typical type of a performance issues. You have an expensive object that you repeatedly create. And as you can see in this case, we show you the impact of this performance issue on your CPU, on your active CPU, which 10%, it's quite significant. And we show you, remember, new feature, the cost of that feature, the cost of that issue, close to $3,000 a year. And we give you an explanation of, hey, this is what's happening. So Jackson Object Mapper is thread safe, and you should create it only once. And then we have suggested resolution steps, and also if you want to see it in the visualizations, we have links for that. So I haven't spoken about visualizations. If we have time on me, we'll briefly cover it. But this is basically your recommendation report, and the anomaly part of the recommendation report is fairly sensitive. So it gets updated every 5 minutes. In every one of those reports, hourly reports, you get updates every 5 minutes. Okay, cool. So
Yeah, just real quick, I just want to connect this to one of the questions that came across in chat. This does demonstrate the fact that this doesn't profile just your own code, right? As you can see here in the Java util zip folder, this is utility package. Some of the other examples you have here. So hopefully that answers the question in chat.
That is absolutely true. And I can give you an example with, we had an application that was using a library, the default Java crypto library, which was causing performance issues. So that's not your code, it's just your code using another library, but it was impacting negatively the performance of your application, and the recommendation report found out about this issue, and it recommended that you change to another library, which in this case is the open source Amazon Crypto Corridor library, which had dramatic improvements on the performance of that application. So yeah, we look at the entire application, and we tell you recommendations that could be any part of the code. With the visualizations, which I would like to go briefly into, you can see your code and other code. So my code, your code, other code.
Yeah, let's see it.
Okay. So let me see if I already opened it. Right. So what you see here, this city skyline almost, is a it's called a plane graph, and it's sort of becoming a standard representation of the stack traces, the aggregated stack traces of what your application is doing for a given period of time. You can see upright that given period of time, which is, I believe, it's a day here. What you see here on the horizontal axis is all these methods arranged alphabetically that you're calling, and on the y-axis, the vertical axis, you see the relationship between this parent and child method. So at the bottom you have your main function that's calling another child, and all the way up to the top. And the interesting thing about visualization is that you can very quickly see what takes a lot of CPU. The reason why is because the width of all these horizontal bars, which are called frames, i.e. the methods, that tells you how much time it takes from the CPU, or the walk log time, depending on what time you're looking at. So if you hover over any one of those, you can see things like the name of the method, class and method name, the percentage that it takes from active CPU time or walk log time. In this particular case, this is 17.28%. You can see how much it costs you per year, so that it gives you an idea of how expensive your code is. I did mention time a lot, so we're going to go very briefly into this. But what I wanted to mention is that we look at the dating two different ways, well, actually 3 different ways. So this is we call it the overview view of your profile, which is looking at the key entry points into your application. So it's in order of so the key operations is something that is logical to you. You know what are the main services that are, or the main operations that are executed. But also, if you want to know the nuts and bolts of your application, you're going to switch to the hotspot view, which tells you what are my most expensive, as in the lines of code that take the most amount of time. And you find them at the top here. So as you can see, right below the main function, you have zip file.getEntry, which takes a little over 30% of your CPU time. And then you can see all the parents that it's calling. And then we have another view. I'm not going to show you here, but if you want to see a specific method and all the parents that are calling it and all the children that it's calling, you can, okay, I'm going to show it because it's right here. So you see, parents, children, so all the occurrences of this method throughout the your profile are observed here. Going back to time, we have the concept of CPU time or active CPU time and latency. So if you're working on a latency issue, you're going to be switching to the latency view, which looks at the wall clock time. This means that even if you're not CPU bound, your application might still be slow. Reasons for this, I mean, there could be many reasons, but one of them is could be that your application or a method is blocked or waiting for something. So when you switch to this view, you have this legend here that shows you the color-coded thread states. So if everything is red, it's great because red is runnable, so it's fine. I mean, it's not fine because if you're spending too much time in runnable and you have this element of surprise, hey, why am I spending so much time? That could be an issue. But the other things to look for are this blue color, which is blocked. You definitely don't want to be blocked. Or the green color, you're waiting for something. You want to look into this to see why this is happening. And if you switch to, again, the CPU view, you're going to see that it looks different because we're not showing you this extra time when your application is not doing anything on the CPU and yet it's taking time. Cool. So these are the visualizations. And I want to point out that both recommendation reports and visualizations are really important. The recommendation reports are this low-hanging fruit, which is really easy to see and fix. And the visualizations they give you all everything that you want to know about your application. They're searchable, by the way. You can search for a frame and yeah, I don't have time for this, but they're very powerful. And if you know your application, you're the best judge of where you're supposed to be spending this time. And if you're not, you want to find out why.
Yeah, I mean, even just the visualization alone, I think, just packs so much value into what is essentially one, I don't want to use the word like single pane of glass, because I think there's other connotations that are more apt for that, but essentially just being able to understand the complex behavior of such a system in sort of one view is extremely powerful. I mean, if nothing else, helps you to prioritize where you are looking in your code base to potentially even make improvements, nonetheless understanding whether some of those are blocked or not blocked. So there's just so many different layers of value that are sort of packed in here in those visualizations. And I know in chat people like Nacho Pants and I think it's SS Tam, like we have a lot of people who are really enjoying these graphs. These look pretty familiar. I think if I'm not mistaken, these were popularized actually by Netflix, flame graphs. For monitoring and observability. So it's really cool to see those, A, becoming more widely used, but B, seeing all of the features and the tie-ins here directly to even dollars and cents paired to certain lines of codes due to this dependency stack. So cool stuff.
We have a question in chat from the King Phil. Is .NET Core supported / on the roadmap?
So it is not supported yet, and we would like to hear from customers who are interested in this sort of support so that we can start working on it. So voice your opinions.
Yeah, that's a great call out. We at Amazon drive roadmaps from customer feedback. We call it working backwards. There are lots of people that have been asking, when is support coming to this language or that language? If you're a customer, you have an account manager, let them know. If you don't have one of those, let us know on social media, let us know in the chat, because we're always looking to build these features out for those that are asking for it. So please.
Yeah, Daniela, when is support coming for Fortran?
Yesterday.
Now, okay, I have a even sillier question for you. What does this look like when you run the profiler on the profiler?
We actually do run the profiler on the profiler. All parts of the profiler are being profiled.
Wow. Okay, there you have it.
I feel like that's an anticlimactic answer, but people in chat were like, "Oh, I'll get you here," and then, we already covered it.
It's secret. I cannot show it to you, but we make sure that our service is running extremely well so that you guys can take the most advantage.
Yeah, it's I joke that we like to dog food our own services, and there are certain services that have really big stories here. But in addition to using CodeGuru on our actual applications here, at Amazon and AWS. Actually, using the profiler on the profiler is probably the most meta example I could probably come up for that. Come up for with that. So, thank you for that.
Great. Just very quickly, and well, I won't have time to do this probably, but you were asking me, Nick, how to start the profiler. You don't need to change any code. There is a way to change code. I'll explain when you want to do that. But to start your application together with the profiling thread or profiling agent, you want to supply on the command line a Java agent with the name of the profiler Java agent, and that's it. And either you want to set up the environment variable separately on the same command line. It doesn't matter. But the point is that it's literally a single command line where that starts your application. There's no need for changing code. Having said that, if you want to start the profiler by changing the code, you can do that as well. And this would be useful for things like running Lambda. And it will be, let's see. To do that, we provide code snippets during the onboarding experience, and it's literally importing there's your import statements, and starting the profiler, and then wrapping the logic of your function in the handler function of the profiler. So that is pretty much it. I mean, it doesn't get any easier than that. It's super easy to start the profiling.
Awesome. So in recap here, we covered a lot here in just the profiler section. But again, introduction to Amazon CodeGuru, two primary parts, sort of the passive and the active phases. The active phase here being profiler, which Daniela, you just showed us in action and gave us a very deep dive on, to be able to profile your applications with no changes to your code. And just there at the end, you showed us an example of what kicking off that profiling actually looks like.
Yeah, absolutely. I'm going to stop sharing my screen. I think we've had enough.
Awesome. Well, trust me, if I could be here all day, I would, if it wasn't for us keeping the other guests that are about to share here. Okay. But again, in the spirit of today's episode, we're doing a fewer launches, but diving a little bit deeper. CodeGuru is one that is definitely befitting of that, again, with these two very different parts, but extremely valuable in their own rights. We're actually going to be right back with a second guest to cover CodeGuru Reviewer. But without further ado, Daniela, thank you again. This demo was amazing, and you were great.
Thank you very much.
Awesome. Sit tight, everyone. We'll be right back.